In this video, we're going to learn how to simplify radicals. In order to simplify a radical, you need to eliminate any perfect squares from underneath a radical. A perfect square is when you take an integer and you square it. I have written out on the top of this sheet of paper the first 15 perfect squares, starting with 1, 4, 9, 16, all the way up to 225. And each of these numbers is just the next integer squared. So 1 squared is 1, 2 squared, 4, 3 squared, 9, 4 squared, 16, and so on, all the way up to 15 squared, 225. We're going to use this list of numbers to help us simplify a radical. Now, for example, if I have the square root of 48, 48 is not on this list. It is not a perfect square. However, we have to determine whether or not it has any hidden perfect squares inside of 48. So do any of these numbers appear as a multiple of another number to make up 48? Let's say, for example, your number sense isn't great and you're not comfortable with trying to mentally calculate numbers. I'm going to show you how to use a calculator to actually find out which of these perfect squares, or if any, go into 48. So you're going to take your calculator and you're going to start with your number underneath the radical, 48 in this case. Find out where it lies on this number line. In this case, it falls in between 36 and 49. So what I tell students to do is to simply start from the next number to the left and start dividing 48 by the numbers in the line until you get an integer factor. Okay, so a whole number. So I'm going to take 48, first divided by 36. And when you do that, you get 1.3 repeating. That is not an integer, so we're going to move on to the next number. 48 divided by 25. 1.92. This is an exact number, but it's not an integer. Move one more down. 48 divided by 16. You get 3, which is an integer. 16 being your perfect square, it goes into 48 3 times. So I'm going to rewrite the square root of 48 as the square root of 16, the perfect square, times 3. In the beginning, I said the goal of the problem is to eliminate any perfect squares from underneath the radical. So we need to move this number to the outside of the radical. And we do that by using the multiplication rule of radicals. If you have two numbers multiplying together underneath the radical, you can rewrite them as two radicals multiplying. And the whole reason we seek out that perfect square because the square root of 16 is 4. Exactly. The square root of 3 is a rational number, so we're just going to keep this number exact as 4 root 3. This number, square root of 48, and 4 root 3 are the exact same number. This is a simplified version of it. So, just to recap, the goal of each problem is to move any perfect squares from the outside or the inside of the radical to the outside. So square root of 16 became 4. Let's try another example. The square root of 256. So, in this example, 256 is bigger than all these numbers on this number line. So I'm going to start with 225 and move left until I find a multiple, I find a factor of 256 that goes into it an integer number of times. So 256 divided by 225 divided by 196. I'm going to keep going on the list. I'm at 144 right now. Still have no integer factors. So now I'm at 100. 2.56, still is not going to do it. Let's try 81. Nope. Let's try 64. And I got 4. So 256 divided by 64, after I did all these numbers, I got to here. 64 is my hidden perfect square. So 64 times 4 is 256. So I'm going to rewrite it as the square root of 64 times 4. Now, what's unique about this number is that it splits up into two perfect squares. 64 is a perfect square. 4 is a perfect square. If you do a problem like this where you're simplifying and you realize that these two factors are both perfect squares, that means your original is also a perfect square. Because if you were to square root 64 and square root 4, you get 8 and 2, and 8 times 2 is 16. Or if you were to do square root of 256 in your calculator, you would also get 16. It's actually the next number after 225 on this list. But if you are doing a larger number and you find out you have two perfect squares after you divide your number or your number line here, your original ends up being a perfect square. So the result of simplifying it ends up being an integer, like 16. Let's do one more example. The square root of 42. 42 lies in between 36 and 49 on this number line. So I'm going to start with 36. Start dividing. So 42 divided by 36. I get 1.16. Repeating. Not gonna work there. 42 divided by 25. 1.68. Not a integer number. 42 divided by 16. That's exact, but not integer. 2.625. 42 divided by 9. Nope, not an integer either. 42 divided by 4. Maybe. 10.5, close, but not an integer. So that means that I have no hidden perfect squares in here. So if there are no hidden perfect squares, I can't simplify it anymore. It's going to stay, as a final answer, the square root of 42. So there's an option where you can simplify it by finding a perfect square that goes into a number, like 48, 16 times 3, and you can move it to the outside. There's an example where the original number might be a perfect square, and you just square root from the beginning, get 16 in this case. The last type of example is if a number inside the radical has no hidden perfect squares besides 1, and therefore simplifying it just becomes the original problem. So these are your three types of situations. Remember, the goal of simplifying radicals is to take any perfect squares that are hidden inside the number, underneath the radical, and move them to the outside. If you possibly have more than one option for perfect squares, you want to find the largest perfect square. Because if you choose a smaller one, you have to repeat the process over again. In this example here, square root of 48, if you were to choose 4 here, if you were to choose 4, which is a perfect square, but a smaller version, it'd be 4 times 12 is 48. Splitting this up, you get the square root of 4 times the square root of 12, and then you'd have 2 root 12. But you are not done because 12 has another hidden perfect square in it. It's also made up of 4 times 3, so you have to repeat the process again. And even though it will give you the same answer, it's just less efficient. This will happen to you at some point. But don't think it's a mistake or anything. It is an okay choice. It's just going to take you a little bit longer. And just to show you how that process would look, this becomes 4 times 3, 4 being your perfect square. Splitting it up looks like this. Notice how I keep the 2 out front. Square root of 4 becomes 2. And lastly, 2 times 2 is 4. And 4 root 3 is your final answer. Notice how it's the same as your original problem here, 4 root 3. It doesn't matter if you choose the largest or the smallest, but the largest perfect square choice in the beginning yields less steps. The smaller choices yields more steps. All right, so we figured out how to simplify a radical by taking any perfect squares that are hidden and moving to the outside of the radical. And that's it.